jump right into it. So our first presentation tonight is from Eric and Thomas from Ledger Wallet, and they're going to be giving a presentation on what's up next with hardware wallets.
I'm Thomas Frank, so I'm a co-founder of Ledger, and this is Eric, my co-founder and CEO. So yeah, we're going to talk about a little bit about hardware wallets, a few examples about what we've been doing, and what we're up to with Ledger. So, a few words about us. So we're a team of 17, based in Paris and San Francisco. So we're mostly French from this cybersecurity space. We raised a bit of money in France, so $3 million. And what we want to do is to provide some simple, safe, and affordable solution for Bitcoin security. So you all know that there's a big problem for Bitcoin. You know about that. When you own Bitcoin, what you actually own are private keys, and because of the decentralized nature of Bitcoin, the fact that transactions are reversible, there's a full responsibility that lies on the user. And you cannot manage these immutable data on regular computers or smartphones that are not designed for that. So there's some different ways to handle these private keys in real Bitcoin. There's this approach to delegate the security to a third party. So you just go to a kind of Bitcoin bank that manages the private keys for you. So Coinbase, Apple, Circle, these are kind of Bitcoin banks that have been gaining quite a lot of traction. And you don't have to bother about security in this approach. Not everybody wants to do that. There's some other solution, let's say software-based wallets, that are actually the the private keys are stored on the smartphone, on the computer, and it's not like malware-proof. There's some ways to, of course, mitigate the risk. You can always have a clean computer. There's some platforms that are most trustworthy. If you go on the keychain for iOS, for example, this kind of thing. And you can also use multi-signature to minimize the single point of failure. But there's also another way that is like paper wallet, so you just print out your paper wallet, put it in a vault, and don't use it. But the problem is that as soon as you're going to use it, private keys are going to be exposed to the network in some way. So one thing that will be needed is actually a kind of air-gap secure environment dedicated to the management of these private keys, where the key generation is made securely, the signature of the transaction are made within that environment, and you can actually validate this transaction with a certain time. And the specialized hardware device can actually do that. And that's why hardware wallets have been having quite a lot of traction. So today on the market, you can say that there's a couple of them. So Trezor has been on the market for about a year or something like this. Is us, Ledger, and also Case that has been launching like a multi-sig hardware wallet as well. So we all have different specificities, different pricing points, different addressable market, but today we are all dedicated on making like a Bitcoin setup. So maybe the best would be to make a little demo of how it works on the Ledger side.
Okay, so it's a little small, but you will be able to see. So what I have done is I have connected the Ledger wallet, which is a smart card on a USB form factor to the computer, to the USB port. And it works with any kind of computer running Chrome or Chromium, so PC, Mac, Linux. And so as you can see here, this is a wallet, and it's an HD wallet. So you can actually have a few different wallets with a large number of addresses. So basically what you have here is like a normal wallet, an interface where you can send, you can receive, you can see your transaction history. And where the big difference is compared to other software-based wallets is when you are going to send. So I'm going to show you how it works. So First, I will just take an address from my wallet, and then I'm going to send, for instance, 1 Bitcoin. And this is a real critical operation. When you are going to sign a transaction, it means that you need a private key, you need to have it not encrypted, and in traditional software-based wallet, it will be in the memory of the computer. And this is where you are at risk. Here, all of the signature is done inside the hardware wallet. But you need to make sure of what you are going to sign. Because if it works as an oracle, like signing everything without verifying, if you have a malware on the computer, it can just modify the destination address or the amount, and then it will sign something and you will lose your Bitcoin. This is why we use a secure. Yes?
So are these real Bitcoins?
Yes. This is not testnet, it's a live net. And you need to make sure of the transaction of the destination address. And in this particular example, I have paired my smartphone to the hardware wallet, and I just have been pushed. So on the push that I receive, I can see exactly what is the transaction that I have done, and it asks me to confirm that I really want to send 1 Bitcoin to this address. And this is a secure pairing between the hardware wallet and this phone. It means that you need to have the phone to make the payments. That means that even if you take my hardware wallet and you take my bill, if you do not have the phone or a physical security card, in case I don't have the phone with me, then you cannot make any transaction. And it is connected using WebSockets securely. And now if I'm going to confirm the transaction, it will go through, it will sign the transaction again inside the secure element, which means the private keys will never be revealed to the host. And so even if this computer is with keyloggers, with all the malwares that you can think of, there is no way that they will be able to steal the private keys or take the Bitcoins. So this is an example of how we can use a hardware wallet. And once it's signed, it will give back to the computer the signed transaction, which is not critical information, and it will just send it to the Bitcoin network. So this is, let's say, the first kind of hardware wallet. It is very compact and it is very resilient. And of course, you can ask yourself, what happens if you lose it? So if you lose it, of course, you have what we call a BIP39 backup. It is 24 words where you can write on a piece of paper. And that you will put in a safe, in a bank, you know, because you need to still have some... Go banks.
No banks.
And so if you lose it, you can always restore your seed and get access to your Bitcoins. And you do not have to use a ledger wallet. It's a standard. And it also means that even if our company goes out of business, you will not lose your Bitcoin. It is because you never know what can happen. And sorry? I didn't hear.
Are you going to pass it around?
With your phone, maybe?
You can pass it and look at so it's okay. I feel safe. Where is it? Okay. So this is the first example of hardware wallet. And let's say that the limitation that it has is a full USB port. It cannot connect to a mobile wallet. Well, it can on some Androids, but for instance, it cannot on iOS. And the next generation of hardware wallets is to have the ubiquity of connection, which means that you can use with your laptop, with your mobile. So it's easier to use in all the circumstances. Also, the problem with hardware wallets, you can say it's hardware. It means that you need to buy something. It comes in a box. Okay, so you need to buy it. It's not very expensive. It's like $30, but still, it can be a pain point because you need to find it, you need to buy it, you need to receive it, you need to have some motivation. And it can be, let's say, a difficulty to scale. So the other approach is to use what we call the secure zone of the smartphones. The technical name is trusted execution environment, and I'm going to show that after. And finally, we can also see what we can do with the open architecture and API from the hardware wallets. So the next generation is to use just contactless hardware wallets. Right now, the Trezor and the Ledger Nano use the USB. You have the Case wallet, which is Wi-Fi, with the GSM, yes. So it doesn't need a computer to work. And you also the next generation that we are going to release in September, which is the same thing that the Nano, but with an NFC card, so which will work on Android phones. The same thing that when you need to sign something, you just tap. If it's a multi-signature, you do not need a second factor, but if it's not multi-signature, then you need also to have a second factor using a security card. So, trusted execution environment, this is the secure zone of the smartphones I was talking about. Now, in all the recent Samsung phones, you have this TV, which has been designed by Trustonic, and basically it's a virtual machine running in a secure environment. It is exactly like having a smart card or a secure element, but in a virtualized way. When you are running inside the secure zone, there is absolutely no way from the Android OS to communicate or to take control of this zone. So it is exactly like you would have a virtualized hardware wallet inside your phone. So the big advantage is that you get all the same securities and secure element, like a dedicated hardware wallet, but you can just download it. So it is much easier to use, and it looks like that. So there are pictures, they are not screenshots, because you cannot do screenshots, in fact, of a secure element, of a trusted execution environment, because all the layers of the Android operating system are completely disabled. So what is running, it's just our operating system, it's running on the C level, and all the UI is a trusted UI, which means that you cannot take screenshots. If you press on the buttons of the Android, it will do nothing. And it will be a secure zone where again we have a full management of the private key. We are going to release a beta version of the Trustlet. This is the name of this product, and it will work with Android and green address. So yeah, mycelium and green address, and we expect in 2 weeks once some of the certificates will be propagated by Samsung. No, on iPhone it is a closed. They do not have this kind of technology. It's a little bit different, but right now there is no possibility. It will be only Android phones.
Keychain, basically, you can use keychain, but you cannot choose to store some data in it, some private keys, some words to make the seed, but you cannot like sign the transaction within the keychain, the secure enclave of iPhone. That's a limitation on iOS.
And then, if you are interested, we can show you a demonstration on our phones of how it looks. And it works right now on the Galaxy Note 4 and all the Samsung S6. And the prediction is that next year, a lot of the Samsung, mostly all the high-end Samsung phones will have the Trustonic trusted execution environment embedded.
Something part of the Knox, Samsung Knox?
No, it is something different. It's the same idea. But it is not the same. It's not exactly the same system. Also, with all these hardware wallets, usually you have like API. You can do a lot of things, and you can do third-party integrations. For instance, with the Ledger Nano, you can also use the key, the hardware wallet, to host a key from a multi-signature wallet with GoldGuide and soon with Copay. Right now, if you want to do multi-signature, like for instance you are an enterprise and you want to do 5 or 10 to make a payment, The pain point is the management of the keys, because it's filed, you need to attend on your computers, and if you use the key, in fact, you can very easily distribute them, and you just need to connect and sign. And we have launched enterprise solutions where you can just buy a pack of 10 hardware wallets. So it's easy for enterprises to do multi-signature. Also, you can do identity, you can do login, third-party login, two-factor authentication just using this hardware wallets. So there is a lot of things that you can develop in the future, and of course, all compatibility with crypto assets, because this is something which will be quite used in the future. So if you have any questions, we'll be happy to answer them. Thank you.
What are the backup ways? How do you back up your data?
How do you back up it?
Repeat the question. Repeat the question.
Yeah. So how do you back up the keys? At initialization time, when you want to create your wallet, it will show you the seed, and it will give you 24 words, and then you will need to write them down on a piece of paper. And in case of loss of your wallet or your hardware wallet, then you will be able to restore access. And you can also restore access in Stadium or Multibit. You do not need a hardware wallet.
Or even Trezor.
Or Trezor, yes. Everything is usually compatible.
The code that runs in the trusted server, how is that deployed on the Android? Is it a standard APK or is it something else? Is it something that somebody could access, potentially disassemble, add some extra stuff, and reassemble it?
So how does the application running in the trusted execution environment is deployed? So to deploy an app in this environment, so it's part of the APK, yes, APK, like of the Android package, or it can be downloaded after, like in-app purchase or whatever, if you want to run it later. And the way it works, you need, in fact, to have it's signed by certificates which has been accepted by Samsung. So to be able to deploy these applications, you need to have been accepted by Samsung and Trustonic. And it also uses some kind of provisioning system using a tab, using a third-party company, which gives you, in fact, access and monitors the way you can install apps. So it's not trivial to be able to deploy apps in these environments, and for sure it cannot be spoofed because everything is signed and it's based on some kind of certificates.
You talked a little bit about enterprises using this for authentication. Could you talk a little bit more about the use cases for that? So I can see, for example, being able to identify yourself on a VPN, or what use cases did you imagine from being able to?
Well, we can show you, in fact.
Yeah, so you have the possibility to use like the Bitcoin address as an identification, and you sign a challenge, and you are identified by your private keys. So it's a way to identify yourself on a service. So this is Italy, Bitcoin Blue, just to show a demo of how it can work. So you can sign in with like a Bitcoin address. You log in with Ledger. It asks you to for this challenge, this address. You sign. Up, and it's logging you in. So you're logged in, and when you come here, like success, you're logged in on that service. So you can use like Bitcoin as authentication protocol as well.
So it's not identity in the way of the legal identity, but you can use, in fact, the hardware wallet either to log in, to identify yourself, or to use as a second-factor authentication. So this is a possibility which goes through the APIs of the hardware wallet.
Any options for altcoins?
Altcoins? Yeah. We have testcoin, testnet. And also it will work with Litecoin, Dogecoin, or there is as long as we have blockchain APIs to be able to get blockchain information, and then we can, it's possible to combine the app to work with Litecoin, Dogecoin, so it will be supported in September, I think.
Right, but I have to contact you guys. So obviously, I have to contact you guys. How it's working and all.
Yeah, if you want to add support of any altcoin, you just need to contact us. There is some requirements. It needs to be aged, like to be BIP32, BIP44, BIP39. So there are some requirements, but and a blockchain explorer.
I would say that you have to, for example, to get your credit card put to the fees at the wallet, the bank, or how that works. How the page goes out.
It works only on the Bitcoin network. It means that you cannot really connect your credit card to this kind of hardware wallet. But with the NFC version of the hardware wallet, it is possible, in fact, to pay on checkout on payment terminal using exactly the same tokenization system that Apple Pay. The only limitation is that you need to find a partnership with a card issuer, which will give you, in fact, the connection to the banking world. So technically it's possible, but it is quite complex to obtain such partnership with banks or whatever, because I'm not so much ready or wanting to explore this kind of integration. But it's possible to do it. It will be, it's in theory, possible to pay just with NFC and hardware wallets with bitcoins and your credit cards.
But today you need so much effort for the state of the usage
connection with the banks and stuff like that.
No, you will need to find a bank who will give you an API to generate virtual credit cards or tokens, so you could pay on normal terminals. So it's theoretically it's possible. We had such a license at the time, but once they understood we were doing Bitcoin, they just so maybe later. Yeah, it's like a virtual machine. So the CPU just changed a bit, and it goes in a different world with a different memory, a different stack of execution, and it just runs an operating system. And it's not Android, it is our operating system, the Ledger OS, so it's very low level. All the code is in C. So for instance, if we want to show an image, well, everything we have to do everything from scratch. And this secure operating system cannot be accessed by the Android system, which means that if you have a malware or like an attack vector on your Android phone, it is not possible for this malware to go inside this secure virtual machine, which means that you have the same kind of certification and guarantees as a secure element, a smart cards, which has been used by the banking system for decades, and it gives you a very strong protection, which means that it wouldn't be possible, in fact, to extract the secrets, like your seed, even if they physically got access to the smartphone. So it's a secure virtual machine.
There's somebody from Trustonic here, so maybe if you...
Yeah, this guy is from Trustonic, so you can explain to him instead so it works.
Is all of your code for that OS on your GitHub and open?
No, it's our firmware is not open source. We have specifications, but why it is not open source? It's because we had to sign NDAs with the chip manufacturer, and the APIs are not public. So it is not because we do not want to publish the source code, but one, we cannot because of the NDAs, because we do not have the right to expose the APIs of the secure elements. And second, it wouldn't be possible for anyone to compile, because to have access to the SDK of secure elements or anything, you need in fact to sign NDAs with the chip manufacturer. So if you cannot compile, you cannot build it yourself, then you cannot help, because you cannot go to the end. But
so all the rest is open source. Everything that we can open source is open source.
Can you use the microphone?
everything that can be open source is open source. So the Chrome app, the iPhone apps, the Android apps, all the companion apps are open source. And also, it's when you write code on a smart card, it's like a tamper-proof code that's provable, and we have a very detailed specification so that anybody can test against the specification and to see if the smart card acts the way it should act. So you can test the generation of C, if you can export the private keys, if you can do all that, and you can verify that it really acts the way it was specified.
So, where are my 500 bitcoins? So, any more questions?
Last question?
The chip manufacturer that you're using and the chip that it's based on.
It is ST microelectronic. The chip on which this is based on is ST microelectronic. ST, yeah.
I'm just wondering whether it itself has a specification and is looked in a manner that it wouldn't enable the manufacturer or somebody manufacturing batch chips to backdoor the chip itself.
Okay, we use, if you look carefully right now, it's like, just quickly, like, what if someone intercepted your hardware wallet or changed it or anything? So, in fact, we use attestation. If you look at the screen right now, when I put inside, it just done attestation. So it just asks the chip to sign a challenge, and because the private key is the ledger private key inside, then it can prove that it's a real one. So even if someone tried to change it, put it with something else, as they do not have our private keys, then the challenge will fail, and then you will see that it has been tampered. Okay, well, thank you.